What's up, physics? Welcome back to the Dirt Bike Shed. Look what I got. Got the skateboard. This is our 1.5 kilogram skateboard. That means it's got a mass of 1.5 kilograms. And if we wanted to talk about how much it weighed, that would mean we're talking about its force down towards the earth. If I had a spring scale that was strong enough, and I weighed this skateboard, this spring scale would read right at 15 newtons. Why? Because the acceleration due to gravity is straight down, and it's 9.8 meters per second. So 1.5 kilograms times 9.8 meters per second gives us about 15 newtons, right? 1.5 times 10. So the reason the skateboard has a weight or a force downward of 15 newtons is because gravity is on the normal. It's straight down. Gravity is straight down. So let's think about something. Let's think about 90 degrees. How can we get a 1-to-1 ratio from 90 degrees? What trig function is going to give you 1 from 90 degrees? The answer? Sine. The sine of 90 is 1. And that's going to come in handy in just a second because I'm going to take this skateboard and I'm going to put it on a little hill. I'm going to put it on a ramp. All right. Now we're on a ramp. And the thing is, I can calculate the angle of this ramp by weighing the skateboard. What? Well, remember I told you just a second ago that the sine of 90 was 1. Well, there's got to be a sine for the angle of this ramp, right? And the angle I'm talking about is down in that corner where it comes up from the earth. Right there, that angle, the angle of the ramp, the steepness of the hill, we can discover it by taking the skateboard, putting it on the hill, let it try to roll down, and I'm ignoring friction, okay? We're going to pretend the skateboard is just coming straight down. The wind is blowing and it's moving the camera, I'm sorry. All right, so the skateboard's trying to roll down this little ramp. And I can tell you right now that the weight of this skateboard on the ramp is 3 newtons. It's 3 newtons. The skateboard only weighs 3 newtons on this ramp. In other words, if I'm trying to hold the skateboard and keep it from going down the hill, I have to pull with 3 newtons of force to keep it from doing that. Let's calculate the angle of this ramp. Here's a better shot of the ramp, everybody. You can see the angle is going to be pretty low. I use this ramp to roll dirt bikes up into the shed. All right, here we go. We got our skateboard. It's sort of greenish color, right? Now, I'm drawing the top view of it, okay? I'm not that bad at drawing, all right? It's the top view of it. Now, the weight of this skateboard is 1.5 kilograms, okay, times 9.8 meters per second per second. And the reason that is because the skateboard, when we're weighing it, is falling straight down towards the earth, okay? It's at a 90-degree angle. But if I take this skateboard, get fancy now, I've got my tool here, and I put it on a little low hill, and I'm going to redraw it now. I'll take the skateboard, and I've got it here on this hill. Now, it's not going straight down towards the earth. It's going, when we're trying to weigh it now, here's the wheels, right? When we're trying to weigh it now, it's going this way, right? Because it's going down a ramp. It's going down a ramp. So, there we go. There's the ground in this picture. So really, we can discover this angle right here. What is theta right there? What is the steepness of this hill? Okay, here's how we can calculate this. You see the skateboard over here normally when it's trying to fall straight down? Normally you say, hey, F equals ma, 1.5 kilograms times 9.8 meters per second equals basically 15 newtons, okay? Now really, what we can say here in this problem is that 1.5 kilograms times 9.8 meters per second times the sine of 90, because there's really a 90-degree angle right here, right, is equal to 15 newtons. Really, we know it's 14 point something, very high, right? What is the sine of 90, everybody? It's 1. So that's what makes us not ever have to worry about it. But let's calculate right now this skateboard on the hill. Didn't we say that you had to pull up with 3 newtons of force to keep the skateboard from rolling down the hill? So now we know that 3 newtons of force is equal to, this is our force, is equal to 1.5 kilograms. That, I don't know why that just did that. Let's try that again. Force equals mass times acceleration. 3 newtons, my board is freaking out, is equal to 1.5 kilograms. I'm going to try not to have a temper tantrum here. 3 newtons is equal to 1.5 kilograms times acceleration, 9.8 meters per second times the sine of this mystery angle. So really, F equals ma times the sine of the angle. So now we can find this little angle right here. Let's do a little math. Let's say 1.5 times 9.8. I'm going to do that real quick. 1.5 times 9.8 is really 14.7. 14.7. 14.7 times the sine of theta equals 3 newtons. Now I'm going to take 14.7. I'm going to put it right here. 3 newtons divided by 14.7. 3 divided by 14.7. That gives me 0.20. So 0.2 equals the sine of theta. And so wouldn't we say 0.2 second sine? The angle of the hill was 11.7 degrees. 11.7 degrees equals theta. Now, don't tell me you can't do that at home, because you can download any calculator on the internet that has your trig functions. I'm going to give you a couple of these to try. I'm going to give you 3. They're all going to be exactly like this example problem. Peace out from the Dirt Bike Shed.